Good afternoon, everyone. Happy spring quarter. It's so good to see all of you. I'm really pleased to introduce Professor Cristina Reynaga-Peña, who earned her PhD in genetics at UC Riverside. She is a research professor in the Department of Education at Tecnológico de Monterrey, and she belongs to the Education Innovation Research Group. Also the doctoral program in education innovation and the master's degree program in educational technology. Her areas of research, of interest in research are the scientific education of marginalized populations, teacher training processes for inclusive science education, and the use of academic makerspaces for the development of educational projects with social impact. Most of her trajectory in education has focused on blind and visually impaired populations. Since 2008, she has continuously offered teacher development workshops and conferences to promote inclusive learning environments. She's also designed professional development courses as well as courses for bachelor's and master's degree programs. Dr. Reynaga-Peña's academic production includes 42 research articles and chapters published in national and international journals, a book for teachers, and 24 registration titles, including 2 patents of educational materials for inclusive education on biology topics granted by the Mexican Institute of Industrial Property. She currently leads multi and interdisciplinary projects, which include participation of researchers and students from various disciplines. And one of these projects, EduMakers, has generated inclusive 3-dimensional materials for teaching students with visual impairments. Some of those products have reached public schools in the state of Guanajuato. And I'm just pleased to say that Cristina and I have had the opportunity to start a collaborative relationship through a partnership between UC Davis and Tech. So we've been virtually meeting for the past year almost. And I had the pleasure to go to Mexico City last week so that we could finally meet in person and do some brainstorming together. So I'm really excited that she happened to be here in California the week after and has taken some time out of her own break to be with us. So if you can give her a warm UC Davis welcome.
Well, first of all, thank you all for being here, and thank you so much, Fahima, for inviting me. I'm really excited about this talk, just because I usually don't talk outside a university where I am, not for a long time. So it's really, great to come back to Davis. I have been here before, and it's a beautiful campus, beautiful people, and I appreciate the invitation very much. So I'm going to give you a little bit of my an overview of if this works. Yes, that's okay. I can just do it by hand.
Okay.
Yeah. Is it? Oh my gosh.
Of course it stopped working.
It stopped working as soon as our wonderful friend came. I don't know how to do this.
Let's enter or return.
I did.
I can get them back.
Yeah, thank you. I see.
It just okay. Here it is. Yeah, I got it. Thank you. I'm sorry about that. So my presentation will have several aspects that I would like to talk about. First, I will talk a little bit about my background, because I think personal background always influences research. Then I'm going to tell you how I shifted, what brought me to inclusive science education. Then I will tell you about the frameworks that I actually consider for all the work that I'm doing. Then I will tell you about how we started into design without being designers. And finally, how our current project came up, which is EduMakers. And it's a multidisciplinary project and a little bit of the research outcomes. Some of this is still work in progress, so hopefully I will be able to show you enough in this short time. So one of the things that I wanted to talk is first as a person. I said personal background really influences my current research. And in this picture, you see you have images of my family on the top, upper top, and the lower top. And I have to say that all the adults I mean, that's a small part of the family. All the adults that you see in these pictures are teachers. So with that, I have to say that my family is composed mainly of teachers. From my mom's side, my grandma and my grandpa were teachers as well. And then all my mom and her siblings are teachers. And on my dad's side, yeah, 4 out of 7 siblings are teachers too. And my grand aunt was a teacher too. So that really, it's something that I didn't consider back then when I studied genetics, but I always say that my genetics turn on. I mean, my teacher, my teaching later in life than earlier, but I really enjoy it. So then you also see images of my 2 kids. I really love my kids, and how do they take into the equation for my research? My son is currently studying engineering in Germany, and my daughter, who is on the left side, her name is Doris. She was little when I moved back after I did my PhD. She was young, and at some point I thought she had opportunities to learn science because I always drag her into science museums and all that. But I noticed that was not the case for the average kid in Mexico. So at some point I was invited to teach in an outreach activity format to students who were in regular schools in Mexico. This started sometime around 2003. And first I worked in regular schools, and then I really wanted to go into rural schools. This is an image of one of the most beautiful experiences I had with kids from rural areas in the state of Guanajuato. Here in the middle are some of the images of the drawings that they were doing back then in that workshop. And then my daughter, always influencing, my path. She had a best friend whose name is Elisa, and Elisa was part of a triplet. And one of the kids is blind. Tomas is blind, and he has some other characteristics like that I did not know how to deal with. But the thing is, their mom became to be the principal of the school school for the blind in Irapuato. And at some point she said, well, you do workshops for children, science workshops for children. Why don't you invite my students from the school for the blind? And I didn't want to, and it had to do with my ignorance on how to work, because at that point I was a researcher at the plant biotechnology research center, where I was in charge of the microscopy unit. So all my workshops had to do with visual activities, and I just didn't know what to do. Still, I went through and tried, and I just felt horrible that I was not providing the same experience for everybody in my workshop. And I thought that wasn't fair. Back then, I really just felt awful and found a way to do it right. And in that path, I started collaborating with a friend who is part of the Museum of Light in Mexico City, where they had offered workshops related to how to convey light phenomenon through the senses. And I thought if he could do it, I could do it. And that's the way I started back in 2005. And something that I noticed, I mean, my image to the right is actually having one of my first workshops with blind kids. And one of the things I realized is that there was nothing to help me show with 3D objects what I wanted to show with images in comparison, right? So we started this project of, then I realized that some of the subjects that I was working from the, for example, being a plant biologist or in a plant biotechnology unit, we did a lot of experiments with plants. So if I wanted to show a sighted kid, about photosynthesis, I could just show them a picture like this. I will try to describe it correctly, but it's a plant and there are leaves, and the sun is on one side, and there's an arrow towards the leaf, and then carbon dioxide, it's like a cloud there, and it's an arrow towards the leaf. And then there's, in that image is also a fruit, indicating that the fruits From the plant, it's a tomato, they produce sugar, and then the leaf, also there's an arrow showing that it's producing oxygen. How do you translate that for someone who cannot see this image? And I searched, and all I found was an image like the one that you have to the right that is produced by ONCE, which is the largest association, is the National Organization for the Blind in Spain, that actually, I mean, it's hard to understand if you see the equivalence. It's a tactile graphic in vinyl. I mean, I don't know if that's the right name in English, but it's a tactile graphic showing or attempting to show the same thing. It still uses arrows, but I imagine that in an inclusive space, kids who are using one or the other will not actually be working together, right? Because one will exclude the other. I mean, if you use a visual image, the blind kid would not work in the same time in the same space with the same materials, and the same with the other image that is completely tactile and doesn't have any color, any letters, and it's hard for to interpret. And that's the way. With that, I would like to introduce the frameworks that that are relevant to the work that I have been doing since then. First of all, of course, is that education must be accessible and inclusive for everyone according to the Sustainable Development Goals. But also my perspective is taken from the social model view of the disabilities, in which it really calls for an end of discrimination and oppression against people with some disability through education, accommodation, and universal design. This model recognizes that it's the interaction between functional limitations and social barriers which actually create disabled environments. So it's not because of a characteristic of somebody, but it's instead is because of the communication and that interaction. As I said, I was unable to understand how to work with blind kids because of my ignorance back then, and that then the solution is really adapt environments for everyone, and that will improve the quality and opportunity. I mean, education quality and opportunities for everyone. So within that, the framework to work with from then on is the universal design for learning that specifically states that if we want to be inclusive, the curriculum must provide all students with equal opportunities to learn using absolutely the same teaching materials, the same curriculum for everyone. And this is where education met design, because we wanted to design materials that, resources, educational resources that could be available to everyone. And that way we, together with students from design, we generated a series of physical objects that will help convey or inform of certain topics. For example, here on the left-hand side, I have a leaf model that opens up. It's made in resin and latex, and it has different colors, and it has all the features that can help me show all the tissues that are composing a leaf, a regular leaf. Of course, we also use live leaves, but this is to show the internal organization of the leaf. It's a big 3D model. And then we also wanted to go a little bit more on the microscopic side. On the right-hand side, I have a 2.5, what we call 2.5D, because it's not flat. It has a little bit of surface and tactile features that will allow me to show the cells that compose it. And then we see the stomata, for example. So we can start talking about photosynthesis. Here I'm jumping all the way, zooming in and talking about a chloroplast, where we started incorporating technology from touch graphics that it basically, we could make a sculpture with a physical object representing a chloroplast cut in half. And then the technology allows this chloroplast to provide with auditory information by, the sculpture is covered with silver, and the silver paint is connected to a transductor. The transductor then goes to the computer and sends the information of different areas, because you can actually separate all the areas. So if you touch the membrane of the chloroplast, it will explain to you about the membrane of the chloroplast. And for that, we had to design, together with engineers now, a program, which I was not even aware of how to do that. But then I figured this was a difficult thing to take to schools because of the price. The cost was really high in doing that. And that's where the new project came many years later, with the idea of sharing more of these resources to the people that really needed it in public schools, in regular classrooms. And then I moved from that research institution, I moved into Tecnológico de Monterrey, and it was just a dream come true because I was able to access students who were working in design, who were in engineering and other areas. So in 2019, we actually started up an international multidisciplinary project where we could actually invite college students to work for the creation of technology-based inclusive resources that were affordable, inclusive, accessible for everyone, and attractive and engaging. So the activities for this project now on take place at the Innovation Gym, which is an academic makerspace at Tecnológico de Monterrey that we have several in different campuses. And here in the images that you see, in the upper part, you see the lab, part of the lab. In the middle, you see Daniel working with one of the machines. There is a router. On the right-hand side, you see Luis, who is actually fabricating some of the 3D pieces that we have made. And here in the bottom part is a group of the first students who dare entering into this project. And we also, I have to acknowledge, we had a really great head start collaborating with Citrus Invention Lab at UC Berkeley. And in the images on the upper part, I thought it was really fun to show the people who are part of the Citrus Invention Lab. This picture is actually outside the Citrus Invention Lab. It's a cartoon of the people who works there. And one of the most amazing collaborators was Chris Myers, who is in the bottom part picture, showing in the background is the Citrus Invention Lab, and it's Chris Myers and me and Leo Glasserman, one of my colleagues from Tecnológico de Monterrey. We came on a visit, and we just happened to walk into the Citrus Invention Lab, and Chris says, yes, I'm into this project. So that was wonderful. On the upper right-hand side, there are hands that you see with little figures, puppets. This is a playful thing. This did not start as a serious project. Some of those hands are probably Chris's and some of the students from UC Berkeley who came and visit. Something I learned from this experience is that academic makerspaces really provide the conditions for innovation and solve challenges. This is the way they are created. That's the way they were conceptualized. And you can see examples of this. On the upper part, some of my students in one part of the project are there working, all the mess on the table. It's part of building and designing and creating and testing again. On the lower part is Excel, working on one of the latest 3D resources that we have created using RFID technology. I will show you some of that. And in the upper right-hand side, you can see what it takes to solve difficult challenges, like that's part of the interior of the Gibral. And you see lots of connections, and you have to know about electronics and mechanics, and to put together and make something work is not something easy. Academic makerspaces, we notice that also favor inclusion and cooperation and sharing. The two images that you see here in the upper part are some of my students who visited UC Berkeley in 2019, and in the lower part, there are images on how they are having conversation with students from the Citrus Invention Lab, students who hang around Citrus Invention Lab, and how we had an opportunity to actually experience this collaboration, trying to make a community, but a community is not made that easy, as you may know, and I'll show you later a little bit of that. So what are the characteristics of the resources that we're making? Well, first of all, they are developed using a mix of methodologies. I learned later that this has a name, and this methodology is rip and mix, and that's why I put the title of my talk. Rip and mix means you put things apart, you separate things, take it apart, and then mix them again to create something new. So we are using elements of universal design for learning and human-centered design. So our pieces are either 3D or 2.5D technology-based objects with tactile features. But with the technology, what it helps is to provide scientific information in form of audio and video, some of them, because they are meant to be used by everyone. They are flexible because the information we can upload it in any language and in any even native languages. That's something we haven't done yet, but it's as easy as putting an SD card with all the audio files in the language we want them to be played. The students then, with or without a disability, can explore them autonomously. So I want to tell you a little bit about the process, not too much into it, because some of our colleagues and myself, I thought it was just as easy as thinking of something and then it will be materialized, but it's not. It's a long process. Innovation really requires first ideation. I have to say that the next few 3D representations that I'm going to show, they have to do with ideas that the students brought. I mean, themselves, they wanted to work on a topic and we just let them do it. And they decided the methodology, they decided the technology they were going to use in order to provide auditory information. So they first had to come with an idea, join the group through a social service program. And then they had to design and more design. And they use different technologies. Some of them work better than others. They learn between disciplines because we didn't have only engineers, we also had designers and educators. And we had all kinds of engineers. I mean, we have biotechnology kids. We have some that are even in administration or, I mean, in a whole different range of fields. They had to prototype their ideas once they kind of figure out how to put them, make them tangent or tangible, maybe I should say. And then test with users and with experts as well. They have to run several iterative rounds in order to improve them. And then finally, we can share them out. So in the images that you see in the upper part, first you see a design of the human body internal organs, how they conceptualize this, how they put it together and how they imagine what was important to say about it. On the right-hand side, Daniel is prototyping some of some of the kits that we send out to schools later on. You will see them later. In this down part, Jox is having so much fun with 3D printing. Each of them have different ideas and they love a technology and they are expert in that technology, but they're also willing to share it with others, the secrets of that. And then there's Luis again. I'm sorry, I repeated the picture. Luis is one of our students who graduated and keeps coming back and helping us in the team. So we have done user tests, some of them mimicking, as you say, Luis there covered his eyes and he wanted to see if the subject that the other students wanted to convey was really understandable and accessible. And on the right-hand side, we have Oscar. Oscar is the guy who's sitting on the extremes right. And he's blind and he is testing some of the textures to see which ones were more friendly to be used with some of the models that some of the representations we're doing. On that same picture in the left-hand side is Cristina, one of our researchers, external researchers who's coming to help and do field observations. Down here, it's me testing some of the materials with one little girl, she's about 8. And then on the right-hand side, we're testing some of the embryology new project with a doctor who's retired and who volunteered to see if the concepts were really understandable. So one of the first things that we took over to schools were kits of 25 pieces that they will reach out resource centers at in the state of Guanajuato. From the special education department from Guanajuato, they found us and they wanted to see if we were ready to share some of the products that we were producing. And this is one of the first ones. So Daniel there has the entire kit. We are using, he used 3D printing technology. We are using also QR codes in order to provide the auditory information and the video information. And the topics are from, cultures of Mesoamerica, which is history for third grade of elementary school. the life cycle of a frog and the life cycle of a butterfly are not 3D printed because the quality of the materials that are available in Amazon is much better. But he put together the pedagogy and the and how to present those to the students in 3rd grade or so. I have to say that even if that kit looks really simple, you know, the set, it really required the participation of all the people that is named here, including ourselves on feedback, on the pedagogy. How are you going to explain this? What kind of activities? I mean, we just show the pieces, but there is activities around it. And the videos that were made and the auditory explanations really required a lot of people. And the testing, I mean, as Oscar is there too, and some teachers for special education were also helping us test. They have labels in Braille, but they also audios and all that have to be understandable for, you know, for the kids. This is another piece that also we took 25 pieces to the schools in Guanajuato. And this is called DigiBraille. And you can see, as you can see on the left-hand side, it's a box. The box has the 6 buttons of the Braille alphabet. And there's a button there to start and to stop, or to advance, actually. And then it only shows 5 letters of the vowels in Spanish. It was just easier to start with one simple set. And what happened is that students from the education program developed these stories about the letters. Let's say it starts with an A, and in Spanish the A is A. So it talks about the ardilla who was looking for their family, and it's a little story, short story that turns on when the letter A, the dot for the letter 8 rises, right? And it says A, and then it tells the story, and then I, and then you, whatever. And there are little stories that are related to that. So it's for kindergarten kids to start learning Braille and be familiar with the Braille system. Very, very modest contribution, but it's engaging for kids, for everyone. The next set is an interactive map of Mexico. So in the left hand, we have a map of the regions, the 8 regions of Mexico. And on the right-hand side, the geographical features of Mexico. And Laura is the one who, I mean, the previous image was of Kenya, who actually had the concept of this DigiBraille. I'm sorry, I didn't mention her name. And here is Laura and Toño. Toño is not in the picture, who actually proposed to do these maps. And they actually made the design and fabricated all the pieces, and then they went to France and the United Kingdom for an internship. And so we completed their work by making all the reproductions, and by they thought about RFID technology, you know, that like to enter a place that you pass a card and then the door opens, you know, something like that. But instead of opening a door, it will display information using the box, the white box that is depicted there. And the design of the electronics and all that was made by Luis, basically, and Daniel and Aias, who were actually helping us reproduce 25 times this to be ordered, in order to take it to school. And the audios that you can hear, instead of just giving facts about the regions of Mexico, they are actually rich in a I would say sound experience. For example, the ones I was telling you about, the ones in Mexico City. We walk with Fahima in downtown Mexico City, and there is organillero. Organel. Yes. How do you call it? No, well, you know, this big thing that look, yeah, that they go around and they play music. Okay. That's something very typical of downtown Mexico City. And so my students decided to include sounds of that and the cathedral, the main cathedral of Mexico City, while they are talking about the region. So I thought it was a unique opportunity to have kids experience other states and other regions without being there, but knowing about the culture and the music and the sounds and the food. So it's a little bit different. That's a little bit of that. I'm sorry. I'm not sure if we had time to play everything, but yeah, that explains how it happened. Oh my God, we have to run. So then we have the human body internal organs. These are the kids who actually did that project. That's something we're going to present at the human computer interaction. It consists of the internal organs. And again, it uses RFID technology. So you take the brain and pass it through the box and it talks about the brain. And then, the kids can actually, if they have colors, contrasting colors, and they can learn about, of it. So something we saw is that from higher education, it's possible to contribute to an inclusive education of children, of young children. But also college students had some gain. They actually learn things. I'm going to show it later, but they also support the generation of inclusive environments. And then we actually started making a community of makers. What does it mean? We also expanded to other campuses. Okay, here are some of the kids that actually did all the work that I just presented. Well, not some of them are not the kids. Cheyenne is the head of was the head of the Innovation Gym, and Rafa is one of my collaborators from Puebla. And we actually made community by sharing time together, by building, by solving problems, by laughing together, by going places together. That was the right-hand side. I mean, every time we finished the 25 kids of something, we actually went and had some beer, I had to say it. And then on the right-hand side, there's a picture of us visiting Guanajuato when we actually deliver the products to to teachers. So what the college students get from participating in this project? We interview them, and we actually wanted to know what they say. So through using a qualitative approach, we found this is work of Montserrat Santillan and Dayanis Tamayo, who actually interviewed kids, and they found several categories where the maker community was really based on teamwork and expending time together and solving things together. And that was part of developing competencies where they actually work together to solve complex problems. You had no idea on the difficulties that we encounter when we're trying to do prototyping to final products. I did not know. It was just a whole experience. But they also had to learn to make decisions, and they had to communicate, and they had valuable experiences regarding, they had to learn technologies like 3D printing and all other, especially this was important through the pandemics because they didn't have access to labs, some of the students. So it was overall an enrichment of the academic experience, but they also developed soft skills related to social intelligence as they are working for something to be inclusive. So here are some of the quotes. I don't have time for you to read of them that actually gave us data that help make those categories. Some of them have the strong conviction that the work that we're doing as a team was for someone, a bigger purpose, an actual impact, right? So anyway, I'm going a little bit quick on this. They also recognize that they were able to solve complex problems. Some of the, in the previous image, what I was telling you, the core team, they are actually bright students, each of them in different fields. So it's only together that they were able to solve the problems that we encounter. They also learned to manage problems. They knew that the success of the project depended on them. Maybe not entirely, but yes, they felt responsible and learned together. Then they also talk about how they had to communicate and convey, especially with other mayors, that were participating in this project. They really wanted to do that, not needed to do that in a short time in order to get all the things out. And they also talk about how they learn to use the equipment and how they learn about technologies. And this is something that added value to the regular class experience. And they also recognize themselves as possible to learn other things. So, so many of them recognize that this is something they didn't think of applying their knowledge on, but now they can do more. And finally, in the last few minutes, I'm going to tell you about this ongoing work and how we started working on health sciences. We had a blind student who entered the health sciences program. She wants to be a nutritionist, and we used different technology to make things faster. So we use the tactile talking tablet by Touch Graphics, and this 2.5D representations are used on these leaves, sheets that are special for the talking tablet. And what happens is that they are representation of the formation of the nervous system at the embryo level. And the images that you see here are represent different concepts, but they are made of pieces that have different tactile features. And when you touch them, the TTT provides the auditory information that we program it to say, right? So you program the area that you want to give information, and then you also provide the information. This is also flexible, but because you can put the information in any language. They also have colors, they have textures, and we want to make this usable for everyone. We actually had one of the embryo teachers who brought the entire group, and he used these representations for like a review of the topics. So this is one of the examples. I'm not going to go into details. That the name of the concept is, well, notogenesis. So the notochord is a flexible rod-like structure, and it's represented in these images where we're talking about longitudinal and transverse sections. So so each of these representations is formed by several pieces. One of them is actually a 3D and shows where the cut is done. And this lower part are several pieces showing the histology. I mean, what's happening in the inside. If you were doing like a microscopic observation, because sometimes you just have to look at it from different perspectives. This, we have to do research on how this helps build mental models of things. They are more difficult than just the previous things that we were doing for elementary school kids, but we are in the process of understanding what's happening. For embryology, we're also using 3D printing technology with sensor activated audio display. So now we have incorporated more arts students who actually design in Blender, and then those files go to be 3D printed, and then they put it on top of a display that has, when you pick up the piece, it will talk with using a sensor that it's, I don't remember the name, but it's Imanes, how do you say it in English? Magnets. Yes, it's triggered by magnets. Thank you very much. So we have contributed to the creation of inclusive educational resources for everyone. But most of it, I think we have really created a community of makers, and it's a multidisciplinary community where everybody brings their knowledge, but at the same time they learn. And it's really such a diversity that really makes us possible to generate what we are doing. Also, the students who participate have something. They gain, as you saw, competencies and skills. So what are we doing next? We really aim to design more 3D educational interactive resources and other subjects. We were talking this morning to Natalia, and I was saying I would, our next step is to work on biochemistry, and I'm happy Hobby's here because we will need a lot of your support to tell us about all these 3D printed molecules. I'll be really, really happy to incorporate whatever it's made by other people, by researchers, and just add the technology to make it more, even more accessible. We also need to work on the curriculum because we really need to modify it. And that goes with teacher development. Definitely, we need to talk about inclusive pedagogy, because even with the excuse of the 3D representations, we are not really reaching as we wish. And we want to extend this work. So we join forces, we attract more talent from other institutions. I mean, this is an open invitation to anyone who would like to contribute somehow, because we think this is a matter of access, of equality, and social justice here is represented. I mean, this is what happens when a kid, this is a tree that is bended towards one side, so it has fruit on it. So inequality means that the kid who is in the side of the fruit will get fruit, and the kid who is not on the side of the fruit, or not where it's bent, the tree, he will not have anything. We try to make same tools, but we still have, we want to provide the same tools, but still, you know, the tree is bent to one side and one kid will get more fruit than the other. So if we really want to equal things, we'll have to provide either different tools, similar but different, but even better, we just have to fix the system in order, if we want to really have, offer equal access to using the same tools and give the same opportunities. And just the last thing is, this is a team. I mean, we have been working with a team of people. Here's Chris Myers. There's Marisol and Mona Minkara and Cristina, who are external to Tecnológico de Monterrey. On the red frame pictures are my colleagues from the school and the Department of Education. Leo, Juan Manuel, Dayanis, Monse, and myself. On the yellow frames are pictures of Patty and Griselda and Lilia, who are part of the design, School of Design, Architecture and Design. And on the lower part, the images of Rafa, you have seen him in previous images, and Jose Manuel and Cheyenne and Asael, who work in the engineering part. So this is just a small core of all the people who have participated. I don't have pictures of all the students. I tried to show you some of them. And we have publications related to the role of academic makerspaces to favor inclusion. And we also have some that are where the students present their work themselves in conferences and meetings. And with that, I will just leave you with my email information. I'll be happy to have any questions. Thank you.